Hi, this is Mr. Manley. This is a quick little video on finding functions that lead to a composite result. So you've probably seen, if you're looking at this video, you've seen videos where you are finding the composition of f composite g of x is equal to, and then you're saying that's f of g of x, and then you're going to know what g of x is and then plug that in and find what f is, or f of g of x. Well, here what we're saying is that in this problem we're saying there is some h of x which is a composition of an f and g, which we don't know what f and g are. So what we're being asked in this problem is what's f and what's g if h of x is equal to, and in this case it's equal to 6x cubed minus 2. So what f and g, if I did the composition of f and g, could lead to this result? I think if I look at the, I mean, it might sound difficult or it might sound confusing, but just look. If I do f of x and I say, well, I'm going to say that f of x is equal to 6x cubed. Not what I want to do. I want to say that g of x is equal to 6x cubed. And then I'm going to say that f of x is equal to x plus, or no, x minus 2. So if that were my f and that were my g, then let's check it. So supposedly h of x is equal to f composite g of x. That's what we have in that statement right there. H of x is equal to f composite g of x, and f of g of x is equal to f of 6x cubed, because g of x is 6x cubed. So I put a 6x cubed in for that g of x. And then what's f of that? Well, I plug that in into the function f. And if I plug that in to the function f for x, I get 6x cubed minus 2. And that is what h of x is. It is 6x cubed minus 2. So it might look a little difficult, or it might be difficult to follow, but let me just look at another one. And I think if you see a couple of them or a few of them, you get the idea, and it's really not too terribly difficult. Let's just name it. Let's give a different name. So say I've got an f of x is equal to x squared minus 3, and f of x is equal to the composition of f and g of x. And the question is, what is f and what is g? And I'm going to say, well, g of x must be equal to x squared. Therefore, f of x is equal to x minus 3. So even if you don't 100% follow this, there's a pretty clear pattern happening. I'm not sure if on any of these problems we switch the f and g, so do be careful of that. Say that I had some other one here. So say I had q of x is equal to 1/2 x cubed plus 1. And that q of x is equal to g of f of x. So in this case, I'm going to say that f of x is equal to 1/2 x squared, and g of x is equal to x plus 1. So there's a very clear pattern here, and I think if you look at these three, the first one that I looked at, and I can just write that down again, that g of x is equal to 6x cubed, and f of x is equal to x minus 2. And if you just look at those three, there's definitely a clear pattern. And then, yes, ideally we would like to know what underlies that and exactly how it's working. I think probably the best way to see how it's working is to go ahead and check it and test it out. But that takes time, and you have to commit to doing that. Now there's another problem of this type here that looks different. So in all those other ones, I had something like squared or cubed plus something. All right, now look at this one here. My h of x doesn't look like, it's not in this form. Okay, so look at what I'm going to do with this. I still have the same idea that h of x is equal. I know what it's equal to, what expression it's equal to, and I know that it's a composition of f and g, and I want to know what f and g are. So I'm going to go, in this case, g of x is equal to 2 minus 5x, and f of x is equal to x squared. Now look at when we check it, and I just really think this is a good idea to check these, because not only do you see if you're correct, but you also get a better feel for how these work. So f of g of x, f of 2 minus 5x gets substituted for g of x, and then the 2 minus 5x goes into the function f, which squares things, and there, that matches what h is supposed to be. So this is just another type of this problem. And so if I go f of x is equal to, and if I just go x plus 1 to the third, what's f and g? Well, I'm going to say, and also I'm going to say f, and that f of x, say f of x is equal to f composite g of x. So what's f and g? I'm going to say that f, I'm going to take g first. I'm going to say that g of x is equal to x plus 1, and f of x is equal to x cubed. Easy as that. So I think if you stop and take a look at that and understand that these are the two basic ideas. I think there might be another one that is maybe a rational, or a potentially rational example as well, which actually sounds even easier. But yeah, operating off of these two examples here, where I've got it of, I mean, what do I essentially have? I essentially have it, it's either in the form, and it's a little bit more than this, but it's basically, it's either this form, x plus c to a power, or it's of this form, x to the n plus c. Maybe we could throw a coefficient in there and say that there might be a coefficient like that. And that's it. Those are the two cases, and you have a few examples of how the cases work.